Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my channel. Okay, so today we are going to learn a new topic which is structural analysis. Okay, so in this chapter we are going to calculate or determine the force inside a member. What is a member? Okay, before I proceed, what is a member? Let's look at this figure first. Okay, if you look at this figure here, is it familiar to you? So we can see this kind of figure or structure here on the roof, okay, or at the bridge. Okay, the bridge is built by this kind of structure here. Okay, so this structure here we call it as a truss, T-R-U-S-S. Okay, so inside this truss here, okay, we have two main components. Okay, the first one is member. So what is a member? Member is actually this one. Okay, this rod here, we call it as a member. Okay, this one. And then, so these two members here, okay, this one here, is connected at C, as you can see here. Okay, so this point C here, we call it as a joint. Okay. Okay, okay. Easy, Okay, so before we proceed on how to calculate the force inside the member here, we need to understand that inside this member here, okay, two kind of reaction can happen, which is compression or tension. Okay, only these two. So what is compression? Okay, so compression, this one. Okay, so let's draw a member like this. Okay, so let's say this is a member. So when we want to compress a member, means that we will apply external force, okay, in this direction. Okay, correct? Okay, so when we want to compress a member, our external force will be like this. Okay, so next, what happened to the member? So the member will create a reaction force. Okay, if you refer to the previous topic, we've talked about reaction force. Okay, because the member here, we try to maintain the shape or its shape here. So it will create a reaction force in which direction? Okay, because it wants to cancel the external force here, means that this one, okay, the force that is created inside this member here will be in this direction. Okay, yeah. And what about this point here? This point also same, because we have a direction like this, means that the member here will create a reaction force like this. Okay, in the opposite direction but same magnitude. Okay, so if we try to label, okay, this one here like point A, okay, point A here, this one point B here. Okay, so if we draw at joint A here, if we draw the free body diagram here, this one, okay, so this is our external force. Okay, this is free body diagram at joint A, and then we will have this one. Okay, the reaction force created by this member here. Okay, we label it as F B to A. Why I put B to A? Because the direction is from B to A. Okay, so what about at joint B? So at joint B here, okay, this one here, so we will have, okay, external force, and then at point or at joint B here, we will also have a reaction force. This one, okay, reaction force, this one. This one here is F. Okay, because the direction is from A to B, so I want to write it down as F A B. Okay. So in this case, okay, if you look at this FBA and FAB, even though this is BA, this is AB, but the value, the magnitude of F BA is equals to FAB. okay, the magnitude, even though the direction is different. Okay, FBA is actually equals to FAB. Okay, so look closely, compression. Okay, the direction of the compression is this one, towards the joint. Okay, this one also, when it is a compression, the force of the member will be towards the joint also. Okay, so in any cases, when it is a compression, the direction of the force, okay, by the member here will be towards the joint. Okay, and that's the key point. So what about tension? I mentioned earlier we have two kinds of force condition inside the member. So what about tension? So tension here is the opposite of compression. So means that we want to, this one, okay, make it in a tension. So means that we want to pull the member. So in this direction. Okay, this direction here. So what happens to the member? Member here will also create a reaction force. Okay, just like when it is in a compression. So what is the direction of the force when it is in tension? So because we want to cancel the external force here, so as you can see here, the force is acting inside, okay, or if we draw, okay, the free body diagram here, okay, this one. So let's say this one is A, this one is B, okay. So at joint A, okay, we will have one external force pointing in this direction, and then the force created by the members when it is in tension is in this direction. So I label it as FAB. So because up there we also have A to B, so let's make it A prime B prime. A prime B prime, so A prime B prime. Okay. So when we want to draw the FBD at point B, this one, so at joint B prime, so this one A prime. So we will have external force like this, and then the force inside the member when it is in tension will be in this direction. So F B prime A prime, like this. Okay. So as mentioned earlier, so this one, F A prime B prime and also F B prime A prime here has the same magnitude. Okay. So F A prime B prime is equals to F B prime A prime. Okay. So now you know already about the condition when it is in tension and also compression. So if you look carefully, okay, when the member is in compression, okay, the force of the member will be towards the joint. When it is in a tension, the direction of the force will be outwards of the joint, outwards from the joint here. That is the main difference between compression and also tension. Okay, so this is the basic of structural analysis. So after this, you will be needed to calculate the force inside this member, and you need to determine whether it is in, the first one, whether it is in compression or whether it is in a tension. Okay, so I will show you on how to calculate it in the next video. Okay, please check here this video. Okay, so see you again in the next video. Bye bye.